Section 4.4, triangle congruence, SSS and SAS. We just took the map test a couple weeks ago, right? Does everybody remember that?
Yeah.
Did anybody get a question dealing with these, SSS or SAS? Did anybody get any questions dealing with that? Chris, you did. Did you look lost when you got them? A little bit?
I got the trick question.
Okay.
That's why I got confused.
Yeah, so these are some geometry terms here. After today, you'll know what they mean now. But yeah, a lot of times I know last year students came in and like, well, what do these letter acronyms mean? And we'll find out today. But triangle congruence, SSS, and SAS. So the first thing here, when it comes up, what does that mean? First one here, vocabulary, triangle rigidity. Triangle rigidity is a property of triangles that states that the side lengths of a triangle are fixed. The triangle can have only one shape. Well, what's that mean here? Okay, if I have a fixed triangle, I'm only going to get one triangle. Okay, so for example, so again, triangle rigidity is it's going to have only one shape. Okay, so triangles are fixed and has one shape. The included angle, this is a key term here. Okay, included angle is the angle formed by two adjacent sides of a polygon. Who remembers what adjacent means? What does adjacent mean? Right next to each other. Nice job. So the angle formed by two adjacent sides, that looks like if I have a triangle here, that would be my included angle. Okay? It is the angle in between two sides. Okay? It is the angle in between. It's included. It's on the inside. It's in between two sides. Next one I have included side. It's the common side of two consecutive angles of a polygon. So again, let's say I have a triangle. Let's say I know these two angles here. My included side would now be the side that's in between the two angles. Does everybody see how that is? All right. Would that be an included angle right there? Why would that not be an included angle? Okay, because the angle is not in between the two sides. Would that be an included angle now? Yes. Does everybody see the difference in those two? Shaking your head, no. Okay, well, let's look at it. You see I have my two sides there? Which angle would be in between the two sides? Or what angle is formed with those two sides? You see how this angle is formed between the two sides? So that's what makes it the included angle. This angle here, is that between the two sides? No, so that's not included. What about this one? Would that one be an included angle? No. So for it to be an included angle, it's got to be directly between the two sides that I know. All right? So let's see what this looks like here. Well, SSS and SAS, here's what they represent. Side, side, side stands for SSS. It is a congruence postulate. It's based off what we just showed with the meter sticks over there. If I know the three sides of a triangle, I'm always going to get the same triangle. I can rotate it, I can flip it around, I can do all you want to it, but it's always going to be the same sides. Or it's always going to be the same triangle. So that would make my triangles congruent. Okay? So again, if I look here, QR is the same as UT. PQ is the same as TS. And PR is the same as US. Alright? Does everybody see how all the sides are the same? If all the sides are the same, my two triangles are congruent, and my congruence postulate would be side, side, side. Alright? Now the next one here gets a little bit tougher. This is another example of side, side, side. But it only shows me two sides. Where's the third side at? Who can find the third side there? Colton? It's in the middle. Wait, notes about that, Colton. It connects to it's the same side for both of them, right? That's what's called the reflexive property. Okay? If it's the same line, it's going to be congruent to itself. Okay? So yeah, this side is actually going to be congruent to itself. So FH is the same as FH. Well, now my two triangles are congruent by the side, side, side property. And then the last one, we have what's called side angle side, SAS. All right? Notice, where is my A between? A is between the two S's, right? So my angle must be between the two sides that I know. Henceforth, I have side, angle, side. Does everybody see how that angle, that's an included angle? Okay. I cannot have something like this. If I ever spell a naughty word, that's not going to work. Okay. And they're like, well, what if I go the other way? Guess what? Still not going to work. All right? The angle's got to be between the two sides. That's what's key on something like that. So let's look at number 1 here. It says, use SSS to explain why the triangles in each pair are congruent. First off, what's SSS mean again, Spencer? Side, side, side. So I need JKM is congruent to LKM. Okay, let's look here first. Let's look at JK. What would I say JK is congruent to? I would say JK is congruent to. Can I say LK? Yep. I agree. JK is the same as LK, right? So I have one side. Great. Let's try another one here. What about JM? What would JM be congruent to? LM. Great. And then my last one. I have two sides there. Where's my third side at? Simeon, which one? KM. What's KM going to be congruent to? It's congruent to itself, yeah. KM is going to be congruent to KM. It's congruent to itself. Why is that? Because it's the same line. That's our reflexive property. So notice again, I have side, side, side. And I have side, side, side. So that'd be an example of the side, side, side postulate right there. All right, number 2. Triangle ABC is congruent to triangle CDA. Okay. Let's start with, I don't know, AB here. What would AB be the same as? AB is going to be the same as what? Anderson. It'd be the same as DC. How about, can I say CD? Right? Because if it's AB, I would say CD, right? Make sure it's put them in the same order. Now, if it's a segment, it doesn't really make that big of a difference, right? But I still want to try and match them up as best I can. All right. Let's see here. AD. What about AD up here? What's AD going to be the same as? CB? CB. Good work. Yeah, be congruent to the one on the opposite side. And the last one, I have two sides. Where's my third side at? Christopher. AC. What's AC going to be the same as? Yeah. AC is going to be congruent to CA. Or it's congruent to itself there. And then there again, I have an example of side, side, side. All right. 3. It says use SAS to explain why triangle WXY is congruent to triangle WZY. Notice, where is the A between? The A is between my S's. It's between the sides. The angle's got to be between the sides. So give me something I know down there at the bottom. What's something I know, Becca? What do I know? I know some parts down there, right? Parker, help her out. WY is congruent to WY. Why? Yeah, they're the same line. Becca, do you agree with that? Yeah, nice job, Parker. WY is going to be congruent to itself because it's the same line. What about something else that I recognize? Quinn, what's something else you know?
ZY to XY, or ZW.
ZW is the same as XW. Does everybody agree with that? How do I know that? It says they're congruent, right? What's the last thing I'm missing here, Reed? Nope. Do I know anything about the bottom sides? I don't know anything about those. Colin, what are you thinking? It looks like it, but do we know that for sure? I agree it might be. But what's something I do know right here? What about these two angles? Are those the angles the same? Aren't they the same? What do these tick marks mean right here? That they're the same. The tick marks mean they are the same.
They're not.
Why are they not even?
Yeah, so we can agree these two angles are the same.
Do you have an example of when it's not?
Yeah, we do. Coming up here. So how would I say those two angles are the same then? How would I say those angles are the same? Claire, how would you say that? It is side angle side, but how would I say those angles are the same? Ooh, can I say angle W? How many angles are at W technically? 3 actually, I see, don't you? I would say angle ZWY is congruent to angle what? XWY. Nice job. Remember, I can always label them with three letters? Yeah. I wouldn't want just angle W here, because technically there's 3 angles at W. That doesn't help me out. Okay? Nice job. And now I would say that's an example of side angle side. Good work. Alright, so I have 4 of them here. It says write which of the SSS or SAS postulates, if either, can be used to prove the triangles congruent. If no triangles can be proved congruent, write neither. A lot of times what you write actually is CBD. Does anybody know what CBD stands for? Cannot be determined. Okay? So if it's not SSS or SAS, you can just say it's cannot be determined. So take a couple seconds, I'd like you to look at these 4 on your own. Number 4 here, if we look at this, it's actually going to be cannot be determined. Now, Mr. Heston rose a good point here. He said, but the angle's not in between. That's key. I agree, guys, we have an angle here, right? I agree we have a side. I also agree they share a side. But the question is this an included angle?
What does that mean?
Include angle means it's got to be between the 2 sides that I know.
Oh, it's not.
Where would that angle have to be?
Oh, no, right there.
Wouldn't it have to be over there?
Yeah, you're right.
If the angle's over there, now is it congruent?
Yeah.
Yeah, my ankles are over here, and now they're congruent. However, if I look at it, that technically spells the naughty word, and that's not a congruency statement. Okay. Number 5. Brock, what do you think about number 5? You say SSS. Brock, shh. Do I know this 3rd side over here? So do I know all 3 sides?
No.
Nope, so it can't be SSS.
Sas, because it's in between the 2 we know.
Do I know that these 2 angles are right angles?
Yeah.
That means they're the same.
Yeah.
So that would mean I have SAS. Nice job. Number 6. Katie, what do you think on number 6?
SAS.
Katie says SAS.
I say no because it's not in between the 2 we know are congruent.
Read. Make that point one more time. Everybody else quiets down, please.
It's not in between the 2 that are congruent.
This angle, is that an included angle?
No.
No, because it's not an included angle, cannot be determined. If, let's say I move that angle, let's say my angles were over here. Now it'd be congruent.
Yeah.
Yeah, but it's not an included angle. Remember, it's got to be the included angle. Okay? And 7. What are you thinking on 7, Wilson? Is that your answer?
Yes.
We call that side, 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 I think. Yeah. And again, why would that make sense? Well, the 4s match up, the 6s match up, the 7s match up. They're all the same. Side, side, side. All right? All right, so let's move on here. Next thing is we're going to show that triangles can be congruent. Okay? So we can show that by, for example, here they say y equals 7. Well, if I have y equals 7, what am I going to do with that 7? I plug it in, and I show that all the sides or all the angles will be the same. So, for example, here, number 8. It says, show that the triangles are congruent for the given value of the variable. It gives me x equals 6. What am I going to do with that 6? Plug it in. So what's 2 times 6? 12 minus 3. That's all right. Jump the gun a little bit. We're all right. 9. Take 6, plug it in the top one. Plug it in. I'm going to get
It'd be Sas.
8. I know all 3 sides, so that would give me SSS. Side, side, side. And all 3 sides are the same. Number 9. It says n equals 3. Spencer, what am I going to do with the n equals 3? Plug it in. Gentlemen, quiet down. What's 7 times 3, Spence? And then I take 3 and I plug it into the other one. 36 times 3 plus 5. Oh, let's see. Blake, what's 36 times 3 plus 5?
36 times 3.
Throwing you on the spot. It's all right.
113.
Nice job, sir. 113. And then I plug the other one in. 3 times 3 plus 8. Are they all the same? Do I have the same sides? Same angle, same sides. So that'd be side, angle, side.
No, 10 or 11.
Last ones. Number 10. It says find the value of x that the triangles are congruent. Okay, now if you look here, number 10. I have 2 sides are the same. We want to know about the middle side. It's the same because it's the same side, right? Great. So I want to show that the 2 triangles are congruent. Well, what value of x would make them congruent? What are you supposed to have to do with these 2 statements? Set them equal to each other. Yeah, if they have to be congruent, it means they have to be equal. So I'd say 20x equals 22x minus 3.6.
2 divided by 1.6.
And when I work that out, I would actually subtract 20x. Add 3.6 to the other side because I like keeping things positive. So I have 3.6 equals 2x. Divide by 2, and x equals, what did you say, Wilson? 1.8. So that would be the value that would show that those would be congruent. That would be side, side, side. Number 11. It gives me some sides are the same. It wants me to show that the angles are the same. So what are you supposed to want to do with those angles? Set them equal. 6x minus 27 equals 4x plus 7. So I'd subtract 4x over. Add 27 over. 2x equals 34. Divide by 2. X equals 17.
Oh, 2. For some reason I was saying 4.
Oh, I thought
Even if it was 4, that would be 36 for it to be 9.
Snikes.
So what shortcut would this one be?
And then you guys were like, no, it wasn't.
That'd be side, angle, side. Side, angle, side there. All right?
Yeah, that was actually pretty good.
Nice job. There's your assignment.